That's how words work. That's how you make a person lose themselves in the crowd. I got it.
Small mentality.
All right, so we're gonna go ahead and get started for today. We're doing 4.3 today, properties of rational functions, and so 4.3 and 4.4 kind of go together. So you can kind of think of those as one big long section. So we'll do these. It's in this book, it's set up separately, but really think of this all together. So 4.3, we're just talking about properties, and then 4.4, we'll start getting into some of the graphs. We do have a few graphs in this section that we'll cover as well. So let's go into this rational function. We mentioned this before in the last test. It's basically if there is an x in the bottom, that means it's a rational function. That's really the main thing. And so numerator and denominator are polynomials, particularly there has to be some kind of x in the bottom, and then we consider it a rational function. So there's some rules that we follow in order to find the y-intercept and the x-intercept. So it says to find the y-intercept for a rational function, we put in a 0 for x. And that's what we would do for any function, just put a 0 in for x to find the y-intercept. But then also, we want to find the x-intercept, want to find that, we're going to set the numerator equal to 0. Now, the reason why that is because let's suppose we put a 0 in there for the y, which is what we would normally do to find the x-intercept. Well, if you put a 0 in for y and you multiply both sides by x plus 2, you would just get the top part is set equal to 0 anyway. So the shortcut for this is if you just set the top equal to 0 automatically, that's going to allow you to find the x-intercept. And so if you were to add the 12 over the other side, you get 2x equals 12, and then divide, and you'd get x is equal to 6. Okay, and then you could also write that, if you wanted to write it as a coordinate, you could write it as 6, 0, but we don't need to do that here. For the y-intercept, same as we would do before in previous sections, you'd put a 0 in there for all of the x's, and this would give you -6. So x-intercept is 6, and the y-intercept would be -6, and that's how you find that. So that's always the rule for rational functions like this. So a function that has a fraction in it, like we have here. Y-intercept, set the top equal to 0. For the, I'm sorry, for the, let's see, you know what, actually I did this, let's see, hold on a second. Yeah, so the top equal to 0 if we want to find the x-intercept. And if you want to find the y-intercept, you put a 0 in for x as usual. So these rules here apply to anything that has a fraction in it. It's always going to be done the same way. So numerator is set equal. So the question is, well, what about the denominator? When do we set that equal to 0? Okay, so if you set the denominator equal to 0, that has to do with your domain and also whether you have what's called asymptotes. And so asymptotes is what we're going to talk about next here. All right, so asymptote, we have two different types of asymptotes, but there's actually 3 different kinds. We'll get into the third one a little bit later. But for right now, we're just going to talk about a vertical and a horizontal. So what a vertical asymptote, that usually occurs at the x value where you're dividing by 0. So if you divide by 0, the graph ends up doing something like that, where as you get very, very close to the vertical asymptote, the graph gets further and further down to like -infinity. And then as you approach from this side, this is going to positive infinity as you get very close. But the graph does not actually exist at the vertical asymptote. The reason why is because that's usually where you're dividing by 0. As it says right here, to find the vertical asymptote, you're going to set the bottom, the denominator, equal to 0, and you want to solve for x. Now, we also have a horizontal asymptote that's here. Now, the horizontal asymptote, the graph, as you see, comes very, very close to, but does not cross the horizontal asymptote. Now, the only time that this is ever going to cross is if you have like 2 vertical asymptotes, then it is possible for the graph to cross over the horizontal asymptote. We'll look at those kind of graphs in section 4.4, the next section. But for right now, we're going to go focus only on these horizontal and the vertical. The horizontal, that only comes into play when you're talking about the range. When you talk about the range, since the graph is never going to touch the horizontal asymptote, that means that that y value is not going to be included on your range. So we'll talk about that a little bit later when we do domain and range of these. There's a few questions that we'll do that talk about that. So again, the range is affected by the horizontal asymptote on these. So let's go ahead and find out, how do you find the horizontal asymptote? Okay, so if you want to find the horizontal asymptote, this is in your notes. There's some different rules that we have here. There's 1, 2, and 3 rule at the bottom. So before we get to those rules, I kind of have to set up some variables first. Okay, so this is, again, finding the horizontal asymptote algebraically. So this means that we don't have a graph to read off of. We just have to find it from the equation itself is what we're doing here. On top, we have a polynomial. At the bottom, we have a polynomial. This is the same variables that we set up before on the last test when we talked about polynomials. The a of n is the number in front of the x with the highest power. The n would be its degree. And then we just go down by 1 all the time, but it's descending powers all the way down. Well, we have the same thing on the bottom also, except we're using a b instead of an a. We have an m to indicate the degree on that. So the b of m would be the coefficient in front of the x that has the highest power in the denominator is what we have here. Okay, so and this is all kind of what I said before. So the rules on this, take a look at the n, and the m that you have here for each one. Okay, so n and m we look at those. So here's the rules that you want to be aware of. These 3 right here. So number 1, if the highest power on the top is less than the highest power on the bottom, then the equation of horizontal asymptote is automatically going to be y equals 0. So if you've got like a 2 up here and a 3 down below there, automatically you just put down y equals 0. That's automatically the horizontal asymptote. If the power, the n on top equals the m on the bottom, like we have a 2 on top and a 2 on the bottom, something like that, then we have an equation to find the horizontal asymptote. It's just these 2 leading coefficients, the coefficients from the x's that have the highest power on both the top and the bottom. So that's both of those. That's the equation for that one. The last one, so here's the third asymptote I didn't talk about yet. The first 2 asymptotes I talked about were horizontal and vertical. There's one more asymptote, and this is called an oblique. It's also called a slant asymptote. So oblique could also be referred to as slant asymptote. Okay, so it's either oblique or slant. And so that what happens here is instead of having it be exactly horizontal or vertical, we have it's at an angle. So we have some kind of slant. So that means that it's going to follow the equation of some kind of a line, y equals mx plus b, something like that. That's what we have for oblique. Now that's going to occur if we look at this polynomial. The highest power on top is larger than the highest power on the bottom, like a 3 on top and a 2 on the bottom, something like that. That's the case where there's not going to be a horizontal asymptote, but there is going to be an oblique asymptote. In order to find the oblique asymptote, we have to use either synthetic or long division. So we'll get into that a little bit later, talking about it. For right now, we'll just focus on the horizontal and vertical ones, but we will do some problems where we have to find the oblique asymptote. Okay, so that's how you know if there is an oblique one, just by looking at the power. So these powers here automatically tell you what kind of horizontal asymptote it has, if any at all. Okay, and then the other way, the way to find it, if you want to find the vertical asymptote, set the bottom equal to 0 and solve for x. So that's the 2 ways that you find asymptotes here. So now we'll apply this to an example problem here. This is the same problem we looked at earlier when we found the intercepts. So now we'll find the asymptotes for those. So for vertical asymptote, again, you're going to set the bottom equal to 0. Okay, so we're just going to do x plus 2 equals 0, and we solve for it, and we get x is equal to -2. When you write your answer must be an equation, and so when you do these in My Open Math, it will remind you for that one to put that in there. Some questions will have x equals, so you just have to enter the number in. Now, if x equals is not written there, then you do want to write the whole entire equation. And if that's the case where you do have to write an equation, the system will remind you. It'll say something like answer needs to be an equation or error or something like that. It'll say to remind you to write it as that. But there's some questions in here that just have x equals with a blank afterwards. In that case, you just have to enter the number in only on that case. So in this case, you just enter a -2, but the actual equation itself is x equals -2. So you do need it to be an equation for that one. Now the horizontal asymptote, I'll just put here that we have rules that we follow in order to find the horizontal asymptote. You have to look at the highest power on top and the highest power on the bottom. Now in this case, the highest power on top is a 1, the highest power on the bottom is a 1. So this, we're actually going to use rule number 2. If n equals m, then we have this equation that we need to follow. So those rules I gave you earlier, 1, 2, and 3, this is a case of rule number 2. So rule number 2, if the highest power on top equals the highest power on the bottom, we're going to do this. So in this case, if we get the coefficients, there's a 2 on top and there's a 1 on the bottom. And so we have a 2/1 there, which means that y equals 2 is the equation for the horizontal asymptote. Now, if it does ask you, for instance, some of these questions in the homework, they may ask you for something like this as well. So ask vertical asymptote, horizontal asymptote, and then it'll ask for an oblique asymptote. Now, in this case, what you would put is none. Okay. There's no oblique asymptote. We know that because the only time you'll ever have an oblique or a slant asymptote is if the highest power on the top is larger than the highest power on the bottom. We don't have that here. We already indicated that the highest power on top is equal to the highest power on the bottom. So if it has a horizontal asymptote, it will not have an oblique asymptote. So these will never be true at the same time. You're either going to have an oblique or you're going to have a horizontal asymptote, but never both. Okay, it's one or the other is what you'll have in these questions here. So sometimes you might have to put there are no oblique asymptotes and there are no horizontal asymptotes, depending on the question that you have. They will ask you that in the homework with it. So if it did ask you for oblique, we'll just say none in that case. And that's all we have to do for this one. We just want to find the asymptotes only. Now there's other questions that are in here where it asks you to find all this information off of the graph itself. So one thing I'll mention here is this is at -6 here, -6 to make that bigger. And this right here, that red line is at 1/2, just to make that more clear, because it may be harder to see coming through Zoom here with that. So -6 is where this red line is at, and this other one's at 1/2 is where that goes through there. Okay. So what it's asking for is they want us to find the domain and range of this. Okay, so let's do domain first. Okay, so domain is talking about all the x values that the graph uses. Now for rational functions, it's anything that's not dotted lines will be part of your domain. But at the dotted lines, the graph is undefined. Wherever you see a vertical asymptote, at that x value, it's not included in your domain. So when you do this, we have to basically include all numbers except for -6 and 1/2. So the way that we'll write that is we're going to go from -infinity to -6. So everything before is included. Then there's everything between -6 and 1/2 is included. So everything in there. And then we've got everything from 1/2 to infinity. So basically, this is just saying you're including all the x values except for -6 and 1/2. Everything else is included. So that's your domain. Now for the range, okay, I mentioned before that if you have a horizontal asymptote, the graph is never going to touch it unless you have more than one vertical asymptote. As we see right here, we see that the graph does in fact cross the x-axis. In fact, there's a dot right there, and this dot is at -3, but it's included. So that means that all y values on this graph are actually going to be included. All the ones going above and below, and it does cross the y-axis in this case. So I know for sure that this particular graph, the range is actually going to be -infinity to +infinity. We are going to look at a case a little bit later in this section where that's not the case, where we don't have two vertical asymptotes, and we'll see that the y value would not be included there in the range. But in this case, it is. All the y values going up are included, going down, and also when it crosses the x-axis, there's a dot there. So that tells us that that's included also. Okay, so it's domain and range. Okay, next we want to find the intercepts. So x-intercept, y-intercept. We'll find the intercepts next. Okay, so x-intercept, as I just mentioned, the graph we see here crossing the x-axis at -3. So -3, 0 would be the coordinate for the x-intercept. Okay, now the y-intercept, we see that that's crossing right there, and it's hard to see, but that's actually at the -1/2 is where that dot crosses right there. And so this will be 0 and -1/2. That's where it crosses. Crosses at this spot right there at that dot. So a little bit hard to see with this picture, but that's where it crosses. Okay, so that's the intercepts. Now we want to find the horizontal asymptote, and we want to find the vertical asymptote. Okay, so horizontal asymptote, we see that as we get really far in the end here, it looks like the graph is getting very, very close to the y-axis on both sides. So this is going to be y equals 0 is the equation for the horizontal. If it's very, very close to 0, it keeps getting closer and closer like that. So y equals 0 is the horizontal. The vertical asymptotes are these -6 and 1/2. So we got to put the x equals there. You do need it to write it as an equation. So x equals -6, and we have x equals 1/2. That's the places where we got these red dotted, or the dotted lines that you see here. Those are the vertical asymptotes right there. We just indicate those. It's a vertical line. This is why we got to start it with x equals. Horizontal lines always start with y equals something. Okay, so we have all that. And then oblique asymptote, we have to say none again right here. I just mentioned that if you have a horizontal asymptote, that means you're not going to have an oblique asymptote. It's either one or the other. So in this case, we have a horizontal one, there's no oblique. And so that answers all the questions for that one. So that one, there will be a question like that in the homework where you have a couple questions like that. They give you a graph and you just have to answer all the questions based off of the graph only. But the other questions that are in here, they don't give you a graph, and then you have to find all this information out by working with the equation only. So let's take a look at some of the ones that are just all algebraically. So here's all the same things we'll do for that. Oops, this one doesn't have a range in it. Let's go ahead and add a range to this as well, since it does ask you that on these questions. So domain, and we'll do range on this question as well. So here's the original question here. Now, anytime you have something like this where it looks like it can be factored, you want to go ahead and factor that first. So sometimes we have cases where we can cancel something out of the top and bottom. So let's take a look at this and factor to see if that happens in this case. The top one is a difference of squares, 1 minus x and 1 plus x. The bottom is one that we can factor. Two numbers that multiply to make 6 and add to be -5. That's going to have to be a -2 and -3. Okay, they multiply to make 6 and they add together to equal -5. Now nothing cancels here because we have no common factors, nothing we can cancel. So now we can go ahead and proceed. It's good to factor this anyway because a lot of these require you to set the top equal to 0, the bottom equal to 0, something like that, which you'd have to factor anyway. So it's good to do that first, just in case something can cancel. So x-intercept, the rule is you're going to set the top equal to 0. So 1 minus x, 1 plus x equals 0. If you solve for that, you're going to get x is equal to 1 and x is equal to negative 1. So if you want to write them as coordinates, 1, 0, and negative 1, comma 0 is what it has there. But usually the way it is here is if it says x equals, it might just tell you to list them out. Don't it may or may not say write them in coordinate form. So just read the instructions for that. If it says coordinate form, we'll go ahead and do that here in this case. Otherwise, it may just want all you have to do is put 1 and negative 1 down for the answer. Y-intercept, you put a 0 in for the x. Okay, so do 1 minus 0 squared over 0 squared minus 5 times 0 plus 6. You can either use the original function, or if you'd like to use the factored version, you can. But in this case, it's less x's to plug into if you use the original one. So I'm doing that, and you'll get 1/6 as a result there. Okay, so 1/6. Again, if it tells you to write it as a coordinate, you would write 0, comma 1/6. Otherwise, it may tell you just to it'll be y equals and there'll be a blank, and you just, in that case, you just put in 1/6. It just depends on what they're asking you to do. As a coordinate, it would be 0 and 1/6. Just depends on the problem. It'll tell you how they want the answers. Okay, now next thing, the vertical asymptote. The rule is you set the bottom equal to 0. So that's our x minus 2, x minus 3 equals 0. If you set both those individually equal to 0, you're going to get x is equal to 2 and x is equal to 3. Again, you do need the x equals as part of your answer, unless it already has that written out already. If it just says x equals with a blank and y equals with a blank, or something like that for the horizontal and vertical asymptotes, then you just type the number in. So in this case, you may have to list them. If there's more than one, you might have to just put 2, comma 3, for instance, if it has the x equals already there for you. All right, next one is the horizontal asymptote, is the rules that we have here. Now the rules, we go back to the original one, and we want to look at the highest power on top and the highest power on the bottom. Now in this case, we see here the highest power on top is a 2, highest power on the bottom is also a 2. So this is another case of you're going to use rule number 2 where n equals m. So you're doing a of n over b of m. Now in this case, we look at the original function here. There's a negative 1 in front of the x on top, and there's a 1 in front of the x in the bottom. So you're going to do negative 1 over 1. And so that means that I would just write out y equals negative 1 as the equation. Okay, so y equals negative 1. That would be the horizontal asymptote, the equation of y equals negative 1. All right, now we want to do domain and range for each of these. Okay, so the domain, when we do the domain actually has to do with the vertical asymptote that goes along with it. So we'll look at the vertical asymptotes. That's going to help me with my domain. I already know that there's division by 0 that happens at 2 and 3. So these numbers cannot be included in your domain. So we're going to go negative infinity to 2. Between 2 and 3 is okay. And then from 3 to infinity. Okay, so it's basically all the numbers, all x values, not including 2 and 3, because we know 2 and 3 causes division by 0. So that's your domain. Now let's talk about the range on here as well. Now the range, we said that the horizontal asymptote was y equals negative 1 on that one. And so let me go ahead and show you the graph. Now this has 2 vertical asymptotes. So the question is whether or not the y value would be included here. So the graph section, we'll get to that in the next section in 4.4. But for right now, I want to, since we haven't learned how to do that yet, I'm just going to show you a quick graph of it. That's going to give you an idea of what's going on. So let me type this out in Desmos first, and then I'll switch the screen over so we can actually see what it is. So I'm putting this one in there as is, and it'll confirm all the other information that we've already looked at before. But we'll go ahead and we'll show this. Okay, So we'll take a look at what this one looks like. Again, we're not expected to know how to graph this one just yet. I'm just showing it to you so you can see. So let's switch to that screen now, the Desmos screen, and I'll show you what that graph looks like that we just did. So here's what it looks like. Okay, so I've got the, as we see here, originally we said that the x-intercept was, so we got 1, 0 and negative 1, 0. So if we zoom in to there, that's exactly right. Negative 1 and 1 is where the graph crosses the x-axis. We also have the graph crossing at 0 and 1/6, which would be about 1/6 is a decimal, so that would be about right there. That would make sense. We have a vertical asymptote. Now, this is Desmos doesn't show that, so just to let you know, when you graph this, it's not going to show it. But if we imagine the line right at -3, so like right at -3 there, that's where the we have kind of like a dotted line, so that would be correct. So we do have a vertical asymptote there. At that point, we said there's one at 3. There's also one at 2 as well. Now, if you zoom all the way out, you kind of see a little bit what's happening here. This would be at 2 and the other one's at 3. So it's kind of hard to tell unless you zoom all the way out in this case, because 2 and 3 are close together. We have this little tiny, the U shape that's on top like that. That one's kind of wedged in between. So the question that we have here on this is talking about the, so actually the range on these kind of questions on this, in this particular section, because we haven't actually talked about the graphing yet, the range is actually not going to be asked because you have to find it off the graph itself. So that's why for some of the original ones, we don't actually have range that's provided unless there's actually a graph given, like the previous example, it was more clear. This one, as we notice, it's a little bit hard to tell exactly where this would go. So for instance, we don't have any part of the graph that is in between here. So if we did want to come up with the range, I'm actually not going to do the range on this. I just wanted to show you that it can be difficult to do on certain graphs, which is why certain questions like this, they're not going to ask you in this section in case you're worried about that. Though if they give you a graph, it'll be like the previous example we did where it's more defined what it is. In this case, if we take a look at this, we'd have to go from like 1/6 all the way up to like 20. That part would not be included in your range if we wanted to do that. Now, though, in order to find out exactly what these coordinates are, you actually need calculus in order to do that, which we're not going to do in this class. So I just want to show you that some of these can get kind of complicated as far as that, but you don't have to worry about these kind of them asking you these kind of questions. So for this particular one, that's why originally in my notes, I only had the domain only. We didn't have the range, but if you wanted to do the range, I just wanted to explain that kind of what happens in this case. So there's a more, so basically the range would go from, this goes all the way down, -infinity all the way up to whatever this little number is up here. So like 1/6, for instance, or around there. And then there'd be nothing, and then the range would also go from like 20 up here, 20 to infinity. But again, to find out exactly how low it is, that's beyond the scope of this course. But I just wanted to show you that as an example that some of these can get complicated, but you don't have to worry about doing these kind of problems for range in this class. That's the reason why, when you go back to notes, that's why originally I just had domain only, but not the range. The range would only be for ones where a picture is provided for you. That's really how you would find that. So you don't have to worry about doing that algebraically because there's not really a way to do that unless you have a graph that is provided. So that's why for this question, we'll just do the domain only. We're not going to worry about the range in this case. So let's go to the next example now that we've gone through all the explanations. I'm not going to do the graphs for all the other ones. I just wanted to show you that one example just to tell you that really for range in this class, we're just still looking at range from graphs only, not really algebraically. That's why all these here, it usually just ask you for domain, but not the range typically. Okay, so let's do this next example here that we've gone through that long-winded explanation. Let's go ahead and talk about this next one, intercepts and asymptotes. This one only asks you for intercepts and asymptotes only, so we don't even have to do domain and range on this particular question here. This is another one, though, that we have to be careful about. We have to factor it first before we jump into something. So let's graph, we'll jump into the factored form first. Okay, so we're going to do y equals on top. We pull out an x, because x is a common factor. If you pull out an x, we're going to get x minus 3. On the bottom, there's also a common factor we can pull out. There's a 2x and a squared. Okay, that goes into each one. 2x squared divided by itself is 1, and then 4x cubed divided by 2x squared, we get a 2x. So again, we have something here. We notice now that an x can cancel out from top and bottom. So if we cancel out the x, we get a reduced form here. We get this. Okay, so the x cancels out. There's still an x in the bottom though, but the top one canceled out, and we got that. Okay, so now we have this left over. The reduced form is the one that we want to look at or work with. So when we do all of our information here, intercepts and asymptotes, you always want to work with the reduced form. Okay, so each of these I was able to take out an x and cancel it out. You always want to do that step first before you find intercepts and asymptotes. Reduce it first if possible, and then find the information. So now that that's reduced, when we set the top equal to 0, the top now, instead of being x times x minus 3, it's now just x minus 3 equals 0. And if we solve for that, we'll get an x-intercept of 3. I'm not going to write these in coordinate form this time, because most of the homework questions will have you just type the number in, and that's it. So we'll just leave it as that. That's 3. The y-intercept, you put a 0 in for the x. Again, we're going to use the reduced form on that. 0 minus 3 on top. We have 2 times 0, 1 plus 2 times 0, like that. Now on the test, which by the way, I'm almost done. I still have, by the end of the day today, I hope to have all your emails I'll send out as far as the test scores. But one thing that I saw, a common mistake that I saw people make on the test is if there's a 0 out front, I saw some people just eliminating the 0 and just writing it as like 1 plus 2 times 0. That's not correct. You're multiplying 2 times 0 times everything. So because the whole thing is 0, we're going to get a 0 on the bottom of that. So that's one thing that you want to be careful about. You don't just disappear and get rid of the 0. If you're multiplying it, the whole thing becomes 0. Now this is undefined. So basically you would say no y-intercept. Okay, so if you get something that's undefined ever for either one of these x-intercept or y-intercept, you're just going to put none down there. And there will be a choice in the homework where you can select there is no y-intercept, and that's what you would put in that case. So there is none because you're dividing by 0. For the vertical asymptote, you're setting the bottom equal to 0. Now the bottom, we're going to use the reduced version, so it's 2x and 1 plus 2x, that equals 0. So if we set both those equal to 0, we get 2x equals 0, and we get 1 plus 2x equals 0. Divide both sides by 0 here, we get that 0 is a vertical asymptote. So actually that explains why we did not get a y-intercept. So if the vertical asymptote happens to be x equals 0, then that's a case where you're not going to have a y-intercept because we know the graph does not cross the vertical asymptote. Now the other one we have, if you subtract 1 and divide by 2, you're going to get negative 1/2 as the other one. Okay, so we get x is negative 1/2. That's your other vertical asymptote. So now we have 2 of them in this case. Let's take a look at the horizontal asymptote. We have to use the rules here. Now we can, in this case, the horizontal asymptote, it is okay to use the original function. In this case, I think it's going to be easier because we can tell right away what the highest power of the top and bottom is going to be. Now in this case, we're going to have a case of rule number 1 this time. The n is less than m. The highest power on top is a 2. The highest power on the bottom is a 3. Okay, so we're looking at the 2 here, and we're looking at the 3. So 2 and a 3, that means you're using rule number 1. Highest power on top is less than the highest power on the bottom. When that happens, automatically we just put down y equals 0 for the horizontal asymptote. There's nothing to work out. There's no work to show. You can just put down y equals 0 because of that case, because of those powers. Highest power on top is less than the highest power on the bottom. So we have that, and that's going to be it. Now, if it did ask you to do domain, it would just basically be all numbers, not including 0 and -1/2, if it did ask you for domain. Okay, so next is another one. This one, we're finding, again, just the asymptotes only. We don't have to find domain or range on this one. And there's no graph yet. We're just finding domain and range. Okay, so another one, let's, for this one here, okay, we want to try and factor this if we can. Okay, now this actually says, you know what, this one, we don't have to find, this is find the asymptotes only, so I shouldn't have actually typed this out. You don't actually have to find X-intercept or Y-intercept in this one. This one just says find asymptotes only. So let's just do asymptotes for this. If it was a case where you wanted to find X-intercept, Y-intercept, you'd have to factor this on top, but I believe this is one that cannot be factored. You multiply 3 times 6, it's 18. And factors of 18 that add up to 10, you're not going to find that, which means that you'd have to use quadratic or something like that. You're not going to have that kind of question in here, so that's why we're not going to bother finding the intercepts in this case. We're just going to find the asymptotes only. So vertical asymptote, you're going to set the bottom equal to 0. And we get x is equal to -2. And you do need the x equals as part of your answer for that. Now for this one, for the rules, the highest power on top is a 2. Highest power on the bottom is a 1. Okay, so in this case, I have rule number 3 in this case. So rule number 3 is where I have the highest power on top is greater than the highest power on the bottom. Now in this case, it says that we have an oblique asymptote. Okay, so we have oblique asymptote and no HA. Okay, there's no horizontal asymptote here because we have an oblique. However, in this case, go ahead and now erase this now so we can see this more clearly. Okay, in this case, what we have to do is we have to divide this now. Okay, because it's not just enough to say it has an oblique asymptote. So it's going to say besides oblique, they're actually to find out what the equation is. So I know we don't have a horizontal, but if there's no horizontal, that means I still want you to find the equation of the oblique. Now, in order to do that, we have to divide this. Now, there's 2 different ways of doing it. In the notes, what I showed you in the written notes was you could do this by long division and get the answer that way. However, you don't have to do it by long division because this is a problem that you can actually do by synthetic division. Notice what we're dividing by. We're dividing by a 1x to the power of 1. That's a case where you can, in fact, do this by synthetic. So although I did this by long division in the notes, I'm actually going to do this instead by synthetic division. Now, if you are dividing it by something that has an x in it, remember that you do have to take the opposite sign of what you see. That's only a case where if you have an x in front of the number, that's the only time you ever have to switch the sign. So in this case, I'm going to switch that and make it -2. I have my powers are all there. I don't have to worry about place keepers because all the powers are there. 3, 10, and 6 are provided. I'm going to drop down to 3. I'm going to multiply these 2 together and put that in the next column. So I have -6 there. I'm adding that together and I get a 4. 4 times -2 is -8. Put that next column. Again, I'm adding when I do the synthetic division. Okay, and I get -8 plus 6 is -2. Now, don't worry if you don't get a 0. I know that on the last test we were concerned about getting a 0 here. That's not the case here. In fact, you'll probably almost always have a remainder. Let's take a look at if we were to write this out as a result of doing that division. Let's see what we have left. Now, remember, we have every time you do synthetic, it's going to take your power down by 1. So originally I had a power of 2, which means that this is going to be 3x plus 4, and then I have this remainder part. And we did this back in the synthetic division section where we talked about division of polynomials. This is how we can write out an answer. Now, when you write your answer for the asymptote, the oblique asymptote here, we're going to ignore the last part. So the remainder part, you're going to drop that. So when you write your oblique, it's just going to be y equals, now you still have to remember to put y equals on there because there's an equation of a line. Okay, so it is this 3x plus 4, and that's your equation for your oblique. Now the reason why we don't use the fraction part here is let's think about what happens when you have asymptotes. When you have asymptotes, you're talking about what happens when x gets really big or really small. If I put a really big number into here, the bigger the bottom gets on that. If I put something in for x, for instance, like 1,000,000 and 1,000,000,000, if you're taking a really small number on top, dividing by a very large number on the bottom, what happens is this overall fraction is going to get smaller and smaller to where eventually it's going to turn into a 0. And that's why we don't care about this last part. We only care about the 3x plus 4, because when x gets real big or real small, this whole thing's going to disappear anyway. It gets smaller and smaller to where it's going to be insignificant and it's not going to matter. So that's why when you write your oblique, it's only going to be the quotient is what you're going to have as a result. If you're to go through the long division part, you would get 3x plus 4 on top up here as well. When we set it up by using long division, whatever your quotient that appears on top, that's what you would put for your oblique. So you can ignore the remainder and just write down the quotient part only, and that's how you're going to do that for this. So there is no horizontal asymptote, but again, if there's no horizontal asymptote, then they want you to do the division and find out what the actual equation of the oblique asymptote or slant asymptote is going to be. So that's how you want to treat those. This is only going to happen when the highest power on top is larger than the highest power on the bottom. That's the only time you ever have to worry about synthetic division or long division, is when that's the case. So higher power on top than the bottom, then you know it's going to be automatically oblique, and you'll have to find that equation by using the synthetic or long division. Now, the only graphing that we're going to get into in this section, and we're just focusing on graphs that have just one vertical asymptote. The ones that have two vertical asymptotes, we'll deal with those in the next section, which we'll be able to introduce that today. But here are some base graphs. So there's a couple questions in here where they give you these base graphs, and they want you to use transformations to find the new one. Okay, graphing it with transformations. So this is y equals 1 over x we have there. So this is y equals 1 over x. Okay, and we have y equals here. We have y equals 1 over x squared. So these are the base graphs. So we have 1 over x, one goes down, and then the other one, we have two things in the opposite quadrant. So we have one thing that follows the horizontal asymptote with a curve, and then follow the vertical asymptote. It does the same thing over here. So for each of these cases, for both these graphs that we have, now the only difference with the square is the square will make the negative part now turn positive. So both will end up going up. That's the difference with the square we have in the bottom. There's a square here. That's the difference. The HA for both of these is going to be y equals 0. The VA, vertical asymptote, is going to be x equals 0 for both of those. So both of them have horizontal and vertical asymptotes are both going to be 0 in this case. And then transformations might have you shift these left, right, up, or down, or flip them. And we'll take a look at some examples now where we have to do that. So the first one we have is y equals x minus 3. It has us use this by transformations. What this is going to do is, because we have this is inside the function, going back to transformations we talked about a while ago. If you have something inside, you're going to move the graph opposite direction of the number that you have that's inside here. So because there's a -3 that's included inside, that means you're going to shift the graph 3 places to the right. It's the opposite direction of what you see here. So it's a -3, instead we'll move it in the positive direction. The original graph is right here. So this is at 0. So that vertical asymptote, that's going to move 3 places over to the right. So that's what your graph is going to look like. It's going to be, just take this, so we shift it 3 places over, And so we have this right here. But everything else is going to be the same. So this part goes down, this part goes up. By the way, these do have key points, which I'll go ahead and put on there, label these for you. Okay, so I have -1, -1, and 1, 1. We also have some key points on this graph as well. This is going to be 1, 1, and this is -1, 1. Okay, so that's what we have as 2 key points on each of these graphs here. So it means the key points are also going to shift over. So that means that I have this one's going to move 3 places over, and it's going to go to 2, -1. So 2, -1 is right there. This point moves over to 3, 1. So that's going to move 3 places to the right. So all these are moving 3 places over to the right. So if we move 3 places over, it's going to be at 4, 1. So right here. Then the graph's just going to look exactly the same as that one. We have this part here, and we have the other part of the graph that goes down like that. And so now it matches with this one. Looks like there's no flips here. Okay, so it just looks exactly the same as the original one down here and one on the opposite quadrant. And that's exactly what we have here. The graph just got shifted over 3 places to the right, and that was the difference there. Okay, so these, the graphs that you have in this section, a lot of them are going to be ones where it's a multiple choice situation where you're choosing the graph off of a multiple choice. And so I'm just taking a look at the homework now just to make sure what I'm telling you is true. Yeah, it's most of these are going to be multiple choice type questions. So there's not really a graphing tool that you're going to use for these. Okay, so these are mostly just all going to be, yeah, multiple choice, so there's no graph at all. So in this case, yeah, it's multiple choice that you'll choose the graph from. Okay, next one we'll take a look at is this one. You know, this one, the next couple of graphs I'm going to show you are ones where you have to do a little bit of work to the graph first before graphing it. First thing I will do here is the bottom part looks like it can be factored. So let's start with that, and let's factor the bottom. Okay, so x and x. Factors of 9 that add up to 6 will just be a 3 and a 3. But I can actually take that one step further and write it as x plus 3 quantity squared, because there's 2 of these together. And I'm only writing it as a square because that way I can look back at my base graphs. So now that I have a square here, that means I need to look at, I'll jump back up here for a second. I need to look at this base graph, y equals 1 over x squared. Now, normally the graph goes up. Now, our particular one has a negative sign in front of it, which means the graph is going to flip. And then the graph is also going to move 3 places to the left. So again, inside here, I see a +3. You're going to move the graph in the opposite direction of the sign that you see there. Instead of a +3, we're going to move it 3 places to the left. Okay, so now we have our vertical asymptote goes there at -3. Normally this graph was going up, but the negative sign here means that the graph is going to do something like this. The graph is going to flip it down like that. So at this point, instead of the key points, again, I move the key points, normally it would be 1 on each side of the dotted line. They're instead going to flip over and move down like this. So it goes down like that, and then it goes down like this. So that's what the graph is going to look like. It got shifted 3 places to the left, that we're reflecting it over the x-axis. It got flipped over because the negative out front, that's the one that does that. The negative out front causes it to flip over the x-axis. So we're flipping it over. That's why it ends up opening down like that. Okay. Now let's, just in case they ask you, some of these are going to ask you for, I didn't have this in my notes originally, but let's do X, for this case, let's just talk about the asymptotes. So VA, HA will do. We're going to do the VA, HA. Let's also do for those, yeah, we'll do oblique as well. So we'll have it identify these. And then we're going to do domain. And we're going to do range on this one as well. So let's answer all this because the homework asks you for these same things as well. Vertical asymptote is the dotted line here. That's going to be x equals -3. The horizontal asymptote is at 0. So y equals 0. Where that goes to, you can see. Oblique is going to be none because we have a horizontal asymptote. Okay, so there's no oblique on this one. The domain is going to be all x values except for where you have a vertical asymptote. -infinity to -3, -3 to infinity. Now the range, the graph only appears below the y-axis. So it's going to go all the way down to -infinity, but it's going to go up to -3. But notice that -3, I'm not going to put a bracket there. I need to put a parenthesis because the graph is never actually going to reach the y value of 0. So it's going to go from, I'm sorry, not -3. What I'm talking about, it should be 0. Sorry about that. -infinity to 0. It's never going to touch the y value of 0. So your range is -infinity to 0 would be the correct answer there. It never crosses that x-axis. That's why the range is only talking about negative y values in this case. Okay, so that's all other information that might ask you on these kind of questions. This last page of notes might look different than what you have. What I did was I added all this stuff to it because again, there's a question here that asks you to find this information on here. So we'll go ahead and find the same information for this. I also added one more example, and this is an example that is really close to one of the homework questions that are in there. So I wanted to do this one for you as well. So this is a late addition. I just added this like probably within the hour before I started teaching this, just because I wanted to throw in one more example for you guys to see. So let's go ahead and do these two examples, and these are a little bit closer to what the homework questions are going to ask you, since my original written notes did not have us go through this. By the way, I did update the written notes that shows all this information with these last two examples, and so you can get those from my Open Math or my website. But the notes are updated here, the guided notes and the written notes for this last two questions here. All right, so let's jump into this. This right here, by the way, what we can do first is we can take this and divide each of these by an x, because we want to get it into a form that looks a little bit more familiar to us. So we're going to get y equals 1 minus 1 over x, or we can just switch the order and make it -1 over x plus 1. Now what this is telling us to do is telling us to take the original graph of 1 over x, it's telling us to flip it over the x-axis, and then we're also going to move it up 1 unit. So that's kind of what's happening on this particular one. Now originally the original graph, if I have this and this is what the normal graph of y equals 1 over x looks like. Now what's telling us to do is it's telling us to flip this graph and then move it up 1 unit. Well, moving it up 1 unit, that's going to raise the horizontal asymptote. The horizontal asymptote originally was at 0, but the +1 in the end, that raises the whole graph up by 1 unit. So I'm going to raise the graph up by 1 unit, but at the same time, I'm also going to flip it. Now, how do we flip it? If we flip this over the x-axis, that means that the part that was down below will come above. So it's going to be reverse of what you see. So my two key points are actually going to be at these locations. This right here was at -1, -1. Well, it'll flip over the x-axis. It's going to become -1, 1. if it was centered at 0, 0. So basically it's one above the dotted line that we see here at -1. The other one is going to be one below because what was above here is now going to flip down below. That's why we have the one right there. So now the graph is going to go through and go up like this. The other one is going to come down and look something like this. So it goes through up this way and down that way. Notice it's reverse of what the original one was. Kind of swapped coordinates there. So that's what the graph will look like. So let's do domain and range for these. Domain is going to be all numbers not including the 0, because if you divide by 0, it causes division by 0 there. Also, it's where our vertical asymptote is. We said the vertical asymptote, by the way, we read that off of the graph. Let's take a look at that first. The vertical asymptote is going to be x equals 0, and the horizontal asymptote is y equals 1. So it's probably better to do the asymptotes first, because that's going to help you do the domain and the range. Domain is tied to the, domain, I just mentioned it, but I wrote it wrong. Domain is talking about all numbers not including 0. So then infinity to 0 and 0 to infinity. That's the correct domain, because you're not including the vertical asymptote there. So not including 0. Your range is going to be from all numbers not including -1. In this case, we don't have 2 vertical asymptotes. We only have 1. So when you look at this, the graph is actually never going to cross the y value, y equals -1. So because y equals 1. So because of that, your range is going to be all numbers not including 1. Okay, and that's how you want to do that one. Okay, we're not including the 1 here because the graph does not cross it. It's never actually going to reach the y value of 1. So because of that, we have to exclude that one from our range. The range is all y values except for 1, because the graph never actually reaches that. For the domain's talking about x values. It's all the x values, but we don't include the vertical asymptote. We see in the original one that if we divide by 0, it's undefined. So that's why 0 is not included in your domain. In your oblique asymptote, we just have to put none. There's no oblique here because we don't have a slant anywhere that we see on that one. We had a horizontal asymptote, so if you have a horizontal, that means you don't have an oblique. Okay, so originally I didn't have all this extra information defined, but I wanted to go through all that for you now, so that's why I changed up these notes to include that, since the homework does ask you for that as well. Let's now do, this is the new question that we didn't have in our notes before. So this is a brand new question, just added it today. So for this, again, we want to first start by simplifying the original function before we jump into all this other information. We're going to do the same technique we did for the previous example. We're going to divide everything by the denominator. Okay, so we're going to just take and divide both of these. We get a 4 and minus 2 over x squared. Or we can also flip the order around and do y equals -2 over x squared plus 4. Right. What we're going to do is let me go back up to the original graph that we have to let that look a little bit more clear if we talk about that. So this, notice what's different about this graph than the one we did before is now we have a 2 on top instead of a 1. The 2 is actually going to affect your key points. Let's go back up here to the original base graph that was provided. Okay, so originally I had 1 over x squared, and that's what the graph looks like. It's one that opens up like this. If you have a 2 on top, what the 2 is going to do is it's going to change the y values. So what it'll do is if it's 2 over x squared, that means I have -1, 2, and I have 1, 2. So these dots actually move up 1 unit. So our base graph is actually going to be what we see here, except that we're going to have 2's on here instead of 1's. So that's what that 2 does on there. So let's go ahead and put that base graph down below. I'm just going to make a quick sketch of it. Okay, so if I have y equals, I'm just going to do 2 over x squared. Okay, then the difference here is I have the graphs are going to go through these points. Still going to go open up like that, but they're going to go through -1, 2, and 1, 2. That's what the 2 does on top. If it was a 3, then you'd have 1, 3 and -1, 3, for instance. Okay, so whatever number is on top, that's what ends up, it's your Y value that you have of your key points. Now, if it's a negative in front, the negative is actually going to flip that down like this. Okay, so negative flips the graph over. So what I'm going to do is I'm going to take this graph, flip it over, and I'm going to raise it up by 4. So I'm going to put the 4 right here. And then the graph doesn't shift left or right at all. It just stays there. But I know that the graph normally would go through the coordinate of 2 above the horizontal asymptote. So now it's going to go 2 below the horizontal asymptote because we said we're flipping this. These points would also flip over like that. So this is kind of like our new, you can think of that as our new x-axis in a way, that dotted line that's there. Okay, so graph flips over, and so now the graph is going to go like this and go like this. Again, this will be a multiple choice in the homework. When you do this kind of question, just choose the correct one. But that's what it will look like if you're drawing it by hand. Now let's deal with the domain. Domain is still going to be infinity to 0, 0 to infinity. We're dividing by x squared. So again, that part there, I'll make this u look a little bit clearer here for us. It's going to be infinity to 0, and then from 0 to infinity. Can't divide by 0, undefined. Now the range is different than the previous one. Now the range here, graph is never going to actually reach 4, but it'll go all the way down to -infinity. So your range on this one is -infinity to 4, but 4 is going to have a parenthesis on it. Okay, so we're not including the 4 here either, but the only difference is we just have one interval only because the graph, both sections point down. That's going to go down to -infinity. Okay, vertical asymptote. Okay, vertical asymptote, we already said was right here, the x equals 0. What that's going to be. Horizontal asymptote is where the 4 on the end that moved up to there. So y equals 4. And again, for oblique, we'll put none because we already see there is a horizontal asymptote here in this case. So there's no oblique in that. So I just wanted to do this one example for you, just so we have a example of this that's in the homework. So there's one like that you'll do that's similar to this one. It's also going to tell you how the graph shifts as well. There'll be a multiple choice. It's going to ask you how the graph moves. So what we're doing, if I want to describe this one, basically what I would say is you're going to vertically stretch the 1/x² graph by a factor of 2. So let me write this out. Actually, it might make more sense. So I'm going to, this question, I'm going to vertically stretch y equals 1/x² by a factor of 2. By a factor of 2. Reflect over the x-axis. Okay, and then I'm going to shift it 4 units up. So you want to look at the different multiple choice. That's going to tell you, but this is exactly what's happening. The graph of 1/x², you're going to vertically stretch it by a factor of 2. We did that. That's what this was when I originally drew the little sketch. Then we reflected it over the x-axis. Okay. And then we're going to shift it up 4 units. So that's exactly what's going on. And so you'll have to select that from your answer choices too. What exactly you're doing, what transformations are required in order to graph this one. And so that's exactly what happens on this. And then it'll ask you for domain and range, the asymptotes, everything we just did here. It'll ask you for all that same information again. So I want to make sure that's clear because again, there's about 4 or 5 questions that kind of ask you something similar with graphing these by transformations. Now, the ones that we're going to do in the next section are a little bit different because these are ones that have more than one vertical asymptote. And so with that, we'll have time just to do, I just want to do one example only on this, and we'll do the rest of these tomorrow. But I do want to go ahead and start the 4.4 section for you, just so you can see an idea, because it is based off of what we just did in the previous section. For instance, all the x-intercepts, the y-intercepts, and all that, that's all going to be the same as what we did previously. So we're going to do in 4.4. This is our first question. So again, for these kind of questions, it is good to factor it first, just in case there's something that you can cancel. This one, there's nothing that can cancel, but it's always good, again, to factor it. X plus 1 over x plus 3, x minus 3. Okay, so x-intercept, you're going to set the top equal to 0, just like we did in the previous section. And we got x is equal to -1. That's where the graph crosses the x-axis. That would be right here. So we can plot that one right there. It crosses at that point. All right, at -1. So that's where it is. Y-intercept, you put a 0 in for all the x's. 0 plus 1 over 0 squared minus 9. That's going to give you -1/9. So that's going to be about right here, just slightly below the x-axis there. So now it goes through those two places. Vertical asymptote, you're going to set the bottom equal to 0. X plus 3, x minus 3 equals 0. Okay, so if we solve for that, we're going to get x is equal to -3, and x is equal to 3. What that would look like on the graph would be these vertical lines I'm going to put in. So I'm going to put vertical lines in for both of these. Okay, so we have that. Next thing we have is a horizontal asymptote we now have for it. So horizontal asymptote, okay, we're going to go back to, let's go back to the original one. Now the original one, there's a power of 1 that's on the x. So I have x to the 1 and I have x squared. To find the horizontal asymptote, these are the rules where you have to look at the highest power on top and the highest power on the bottom. Now in this case, what I have is I have an example of rule number 1, where I have n is less than m. Highest power on top is less than the highest power on the bottom. Automatically, it's going to be y equals 0. So with our graph right there, we have the x-axis just so happens to also be our horizontal asymptote. So now we have everything complete, except we're ready now to graph this one. Okay, now in order to graph with ones that have 2 vertical asymptotes, what's going to happen on the ends here, the graph is either going to be above or below the x-axis. It's going to follow the x-axis curve and follow the vertical one. It's either going to go above or it's going to go below. Now we don't know. The graph is not giving us enough information. What I laid out here doesn't tell us enough information to know whether the graph is above or below. So because of that, we have to use a test point on this. Okay, so test point we have to do. So we're going to test x equal, I need to know what's happening beyond to the left of that vertical. So I want to try -4, but I also want to test x is equal to 4. What I'm going to do is put these into the original equation. So the original equation I have here was y equals x plus 1 over x squared minus 9. I can just use the original in this case. Okay, that's the original equation. I want to plug these into the original one, and that's going to tell me whether the graph is above or below. In fact, it's going to give me a point that I can plot on the graph, and that's how I can tell. So if I plug this into here, I get -4 plus 1 over -4 squared minus 9. I get -3 on top over 7. So that means that the graph is going to go through -4 and -3/7. So -4, -4, -3/7 will be about right here. That's going to tell me then that the graph belongs in the bottom section. It's going to follow the horizontal asymptote, hit this point, it'll curve and go down and follow the vertical. That's the only behavior this graph is allowed to do in this section. It's not going to go down and go up and make it a U shape or anything. It's going to follow one asymptote, curve, and follow the other one. So that we know for sure the graph will look like that. Next, for x is equal to 4, we have y equals 4 plus 1 over 4 squared minus 9. And that one we get a 5/7, which means the graph is going to go through 4 and 5/7. So 4 and 5/7 will be about right here. Now it tells us the graph is going to be in the upper portion, like that. So now I know that that graph is going to look like this. So now I have the two end pieces. That's how you can determine what the end pieces are. Now, in the middle, between these, okay, so between, I'll just write this down below here, between two VAs, okay, the graph is going to look like these four shapes. It's going to look like a U shape, upside down U shape. It's going to look like a cube, or it'll look like a negative cube. Okay, so whenever you have two vertical asymptotes, these are the only four things that the graph could look like. So it's to be one of these shapes. I'm going to select the one that matches the information that I have here. So notice that I have these 2 points like this. So the graph is only going to be one of these four shapes. So if I have a U shape here, that means the graph would have to come down. It would have to go through and hit the x-axis again. Now that's not going to happen in this case because I only have the 2 points. I only have one x-intercept there. Okay, so I know it can't be a U shape like that. The other shape like this is the only one it could be. So this one on the end here, this negative cube shape, that's what it's going to look like. It's going to follow this vertical asymptote. It's going to curve and hit these 2 points, and it'll curve down here and follow the other vertical asymptote like that. That's the only one that could possibly match in this case, because out of these four shapes, it can only be one of these four shapes that's between the two vertical asymptotes. And so in this case, that's the only one it can look like. Now, sometimes the graph may give you enough information to determine what the shape looks like. If we weren't sure about this, then I would have to do 2 more test points in between the middle here, and that would tell us a little bit more information. So if you weren't sure what the graph does, you could certainly test x is equal to 2, or you could test -2, for instance. That would just give you a couple more points up here and down there. Would give you a little bit more information about what the graph looks like. But these are just basically going to be kind of sketches, is what we're doing there in that case. And so that's how you would do that. Now, one thing that this graph, there's one extra question that I didn't have here in my notes that has to do with this graph, and I'm going to finish this with this last question. So it says interval where f of x is above x-axis, and interval where f of x is below the x-axis. Okay, so it is going to ask you these additional questions in here. So I want to go ahead and do that for this one I just did. So that way you have an idea of how to do it. Okay, above and below the x-axis is kind of like what we did before on the last test when we did those inequalities with polynomials. You're looking for the part of the graph that is below the x-axis and above the x-axis. And we're going to use our picture that we just drew in order to answer that. Now, below would be this section right here. So if it's below from -infinity to -3, okay, so let's do below first. -infinity to -3. But then the graph is also below the x-axis on this section here, starting from -1 to 3. That's the intersection where the graph is below the x-axis. Okay, now it says below, but not on the x-axis. Okay, so I don't want to include this x value, but starting from the x value of 2 to 3, I'm sorry, -1 to 3, that's where the graph is below the x-axis. So I'm going to put here -1 to infinity. Okay, now I'm not including -1 here. I'm putting a parenthesis in that case because it's not saying where it is on, it's just talking about where it's below. So on these x values, the graph is below the x-axis. From the x value -1 to the x value of 3 is below. So sorry about that. I put, that should have been 3, not infinity. Apologies there, -1 to 3. Okay. Okay, so -1 to 3 is where that graph is below. Now above would be this section between -3 and -1. Between -3 and -1, the graph is above the x-axis. So I'm going to put that here. Okay, -3, -1. Okay, and then from the x value of 3 to infinity, the graph is completely above the x-axis at that point, because this is a horizontal asymptote, which the graph will come close to but never cross on the ends here. The only place it crosses is right here in the middle. Between the two vertical asymptotes is the only place you'll see a graph crossing the x-axis. Otherwise, when you get real big or real small, the graph just follows the y axis all the way down, x-axis all the way down. In this case, so this is going to be from 3 to infinity. In this case, okay, so 3 to infinity. From the x value of 3 to infinity, the graph is above the x-axis. So this is some additional questions. I didn't have this in my notes originally, but just wanted to make sure we understand this because the homework does ask this kind of question here. So that's why I want to go ahead and talk about it. That's as far as we're going to go for today. So that's it. I just wanted to do one example of 4-4 for you to get you started, but we'll continue. We'll finish this section up next time. So at this point, I'll just stop and see if anybody has any questions. So if not, then you can feel free to leave the meeting. Otherwise, if you have a question, then let me know. Any questions out there? All right, sounds like nobody has any questions. If you think of something again, just go ahead and email me, or you can ask me next time. But if somebody has any questions, we'll go ahead and end this meeting. Enjoy the rest of your day. I'll see you guys tomorrow.